So what will you say to a round of, how is it called? Typing test? Type racer. Yeah. Why is this so? Oh, I think for me the night light is off, is on. Yeah, that's better. Raise your friends. Type racer. If you want to join, we will do this as a warm-up for first few minutes, and then we'll move to solving Leetcode. On YouTube, at least, you can see links to the two homework problems. We will discuss them after that. We will first do Koko eating bananas, and then blocks to spell word, and then I will take suggestions from you about Leetcode problems. John Race. This is homework problem. Solving DP problems today? Yes, that's the idea. I think most of the problems, not counting the two homework problems, will be dynamic programming. Force of audio. $96. Someone please copy again. You can always, temporarily go to YouTube, and YouTube allows you to easier access chat history. Like 2 or 3 more rounds, and then we do Leetcode. One second left. Congratulations to 2 guests for second and third place. Oh, I didn't hit. No. Why is it not automatic? Is the race on? Yes, it is. Okay, that's fine. So this one and one more race, then we start. This sounds like a better start than just me waiting for people to join. Nine seconds. From next week, earlier timings? Yes. Starting from next week, I will do 5 p.m. European time. And still the streams will be for around 2 hours. The difference comes from daylight saving time, where half of my viewers are from India, and for them then it's the middle of the night. Where I also have some viewers from USA, not that many, but still for them this 5 p.m. will not be that bad. Did I miss it again? Damn it. Okay, then one more. How can I join the race? I think you can't now. Sorry, next time I will be more careful with this. Joining race. Oh, I can, it's just late. I'm not going to finish, but good to know that I can start late. Missed this one too. Good evening, everybody. Good evening, Gupta. Yeah. This Saturday we will do easy code forces problem solving, unless there is some code forces contest. Also, all code forces contests for me, they shift to 1 hour earlier. And in the middle of November there will be several unusual streams, because there is Topcoder open and there will be coding game. I will do live commentary of Topcoder open, just like I did a year ago or 2 years ago, a year ago. But then it was on site. Might be full, I see. So that's the issue. Once I'm out, I don't have any priority in joining. I can live with that, so good luck to participants, and I will just start solving Leetcode problems. Just had a sad coding game where I lost to Pythoners. I'm sorry to hear that. What do I want? Custom commands. Did I tell you already in the previous stream that my Linux stopped working? I upgraded Ubuntu from 18 to 20 and it stopped working. I cannot run Linux. But I installed today and yesterday, I installed virtual machine in Windows. And I think from now on, whenever I need Linux, I will just run it here within Windows. And then I will be able to use like OneNote for drawing, the same recording software. It will be much more convenient. Congrats to Sandro for winning 96 words per minute. To Rafael, second place, and the guest for the third place. Yeah, let's finish this and let's move to solving problems. Quick update of a link. What I'm doing today. This save. Koko eating bananas. I'm ready. Exclamation mark link should work. Cool. Let's do this. The plan is Koko eating bananas, homework problem from last week, then this second problem, and then dynamic programming problems suggested by you. But first, Koko eating bananas. If you saw the stream from a week ago, you know what technique we need to use. And the hint was, what happens if it helps to know the answer? If knowing the answer, you can compute one of parameters from the input. Then there is a technique we need to use. Binary search. Binary searching the answer. Let's read the problem. Koko loves to eat bananas. There are n piles of bananas, each with some number of them. There is some time to eat them. Koko can decide her bananas per hour eating speed. That's a stupid statement. I don't think somebody chooses this. Okay, maybe they can. You can hurry or not. Each hour she chooses some pile of bananas and eats k bananas. The speed. If the pile has less than k bananas, she eats all of them instead. Likes to eat slowly, but still wants to finish eating all the bananas before the guards come back. Return the minimum integer k such that blah blah blah. Yep. Why can't I scroll? Okay, I can. Draw. Let's work with example 3, 6, 7, 11. If those are piles of bananas and your speed of eating k is equal 4, then the time needed to eat all of that, well, if we have a pile with 11, you can eat 4 of them because you eat 4 at once, then it will be 7, then it will be 3, and then 0. You need 3 hours, or 3 what? Yeah, 3 hours to eat this whole pile. And in general, if this is AI, you need AI divided by k with a ceiling, that many hours. So you need the sum of this is how much total time you need if you know that your speed of eating is k. Sum over all I of this value. And here it does help a lot to know k. Then we can compute the time needed. So knowing the answer helps us to compute some formula. Then we use binary search over the answer. I binary search this k and just check this total time. This is the sum of times, let's say, sum of times. And whether this total time, whether we can do it or not, whether we have enough time or not. In this example, we see that we are allowed 8 hours. And we can use 8 hours because then the guards will come back. If we got that this value is 6, then it means with this speed I can eat all the bananas before guards come back. So I can achieve this k. Maybe I can then achieve better k. They told us to minimize k. So if for k equal to 4, we got 6 as the total time, the sum of times of eating everything, then we say that 4 is a possible answer. Maybe we need to return that, but also maybe there is a better one. So we go with to smaller interval. We say high, the upper limit in binary search becomes 3. And I think that's it. Nothing more here to say. How do I want to... Oh, not what I wanted to do. I wanted to have this here. Minimum eating speed. Yeah, the code more or less is this. But of course you need to decide every value. High is something, while low smaller equal high, mid is the middle, and you compute the total time needed. For every AI in the sequence of piles, you say sum of total time plus equal the ceiling. For now this is pseudocode. Ceiling of AI divided by k. This is exactly what you see in the red, written in red. And now, if this is good, so you are allowed to spend that much time, you say that this is possible answer, and you try to find a better one. Not ST, this is mid. Mid is that, oh, let's use K. K is our candidate for speed. Okay, like that. Else, oh, it is impossible. With speed equal to 4, we cannot, we are not fast enough to eat everything before guards come back, so we need bigger speed, because then we will eat faster. If you are not sure what happened here, watch my video on binary search. This is value we return if it's possible that nothing here, if nothing here allows us to be fast enough. Also, I think low is 1. With speed of 0, we will not eat anything, and also we will have division by 0. High, well, I will put here int max, but then the issue is this can be long, I think. The total, actually it doesn't even depend on that. If values are big, like 1 billion, 1 billion, 1 billion, and you try the speed of 1, here you will have billion over 1. If you add a lot of those, you need a long for the sum. And finally the ceiling, because in C++ you round things up, this is a way to do it. I will not go into detail. Explain it in some other streams, but yeah. To compute A divided by B with a ceiling, you do this. For example, to compute something divided by 10 ceiling, you add 9 and then you do the floor. You can think about it later if you're not sure what happened there. And done. The complexity is logarithm from binary search multiplied by linear, because we iterate over piles. So it is of n times log of value, where value is just limit for the answer. If something is wrong, I will fix that. I don't see anything wrong. Maybe also this vector can be empty. Nope, everything is fine. Also, we can see that I solved this problem half a year ago. Maybe it was the time when I created the lectures for binary search. Yep. Reading the chat in case there are questions. High can be max of all. Dush, you are completely right. There is no reason for the speed of eating bananas to be bigger than all values from the input. Like here, if the piles are of size 3, 6, 7, 11, speed bigger than 11 doesn't make any sense. Like speed equal to 11 and speed equal to 100 is the same. So either we can look at those limits. I didn't really look at them before, I just assumed they are integers. If this is up to 1 billion, then I can put a billion here. This is correct. But also I can do max element of piles.begin, piles.end. Yep, do I need this returns iterator or value? I don't remember. Maybe we need to put a star here if it doesn't compile. Yeah. So max element returns iterator to the biggest element. Okay, so this will work as well. And complexity is n times logarithm of maximum value in the input. And also this value -1 doesn't really matter. I can put here 123. In my binary search, it doesn't matter. This is just value that I want to return in case I don't find any proper value in my interval from 1 to high. And it would be possible, maybe there's, oh yeah, this is a limit for that. Imagine what happens if h is equal to 2 and the piles, can I make this bigger? No, maybe I will draw it. Instead, imagine that there are a few piles, like piles are 5, 6, 7, but h is equal to 2. No matter what is your speed, each pile must take at least 1 hour, so you will not do anything. If this was a possible input, they would need to define in the statement what to return in this case. Because in this case, you need to say impossible. Even if your speed is infinite, you will take 3 hours, because you cannot combine piles together, no matter your speed. So in this case, my program will return whatever I chose here. And I chose -1 because it's quite reasonable. But putting 123 here would be good as well. It's just that here at least one good value will be found, so answer will be overwritten with a proper answer. Okay, I'm looking for more questions. First Twitch, then maybe also a look at YouTube, but I prefer Twitch chat. I don't want to read both chats. Some details like this one are explained in binary search lecture. I don't want to repeat everything from the lecture. If values are small enough, then you can also say low plus high divided by 2, also if they are positive. This is just a better way to do it. You can think about differences. Do you use lambda functions for small pieces of code? Yes. Yes, I do. But here, I don't think this code will be better if I put this as a function. Maybe a little bit, but this code is anyway so short. The one line with declaration of a function is kind of almost longer than what we have here. Good to finally catch a stream. W. Folina, you're welcome to watch it. Glad you joined. So answer will be inclusive of the min-max range. In my binary search, always from low to high is a range in which I'm looking for the answer. If this range was from 1 to 5, then I'm going to check 3. Maybe 3 is possible answer, maybe not. And then I go down to interval 1, 2, or to interval 4, 5. Are you taking suggestions today? After I'm done with homework. So suggestions later. Okay, now what's up on YouTube? Questions about this problem first. This problem being Koko eating bananas. Also, when I'm saying, for example, check out my binary search lecture on YouTube, I won't always give you a link because you can easily Google. You type YouTube, when you hit tab, you will search on YouTube, and now Errichto binary search. I'm sure you will find it here. Yeah, the first thing. Also, if you just Google YouTube Errichto binary search lecture or tutorial, you will find it. If something is easily Googleable, searchable, then I'm not always going to provide a link. I don't see more questions about our 6-hour-long video, but not the lecture, right? Where? Oh, this one, binary search. This is a stream where I tried all possible, maybe not all, a lot of possible binary search implementations. I do some research before a lecture. Like this lecture is just half an hour, and this is what you should watch. This one is more like, I'm trying this method, this one, oh, this is interesting problem when this method doesn't really work better, blah, blah, blah. And then I chose the best method and I explained everything here. Because binary search can be implemented in multiple ways. Boring programming streams were the real days. But also it was a very long and kind of boring stream. Okay, next problem. Blocks to spell word. This is the second. Yeah. I prefer this website with dark reader on. Let me update the link real quick. On YouTube, you have the link in the description. Here you go. Blocks to spell word. I hesitated to give this as a homework. And the thing is, for competitive programmers, this will be very easy and standard. It doesn't make any sense. It's educational. For beginners, at some point, I would suggest this problem. But that's it. In coding interviews, this topic rarely happens. But it does, so I accepted this suggestion for homework. You're given a list of lowercase alphabet strings, words, and a string target. Assuming you can pick at most one character from each string in words, return whether you can spell out target in any order. Example, you can use one letter from how, do, I, shot, web, and you need to create a word wow. You can do it by taking W from how, O from do, and another W from web. The order doesn't matter, so you could shuffle around those strings and the answer would still be yes, it's possible. But you can only take one character from each string, and the second example shows that. Even though every letter exists here in words, there is B, I, N, A, R, Y, but you cannot take both B and I. You can think here about various greedy approaches, but two things about that. One is, we will try to find counterexamples to those. Second, if there was a greedy approach, why would limits be so small? If you see constraints up to 10 or up to 20, either it's a very easy problem and creator of a problem didn't really care about constraints or about your complexity. He says, whatever, you can use n square, n cubic, n to 4th power, 2 to nth power, everything you can use. But most likely, the intended solution is slow. If n was even smaller, we could, for example, iterate all orders. N factorial would be small enough. N factorial is complexity of just checking all the possible permutations and comparing them with something. But yeah, if n is up to around 15, then that's a hint why you should consider this complexity. 2 to nth power. In competitive programming, limits are tighter, so then, or more tight. Then it's more common to see n up to 20. Also, this doesn't matter. I can actually erase n up to 20. But in coding interviews, different languages are allowed. Some languages are slower, like Python or JavaScript. So instead of n up to 20, maybe you will see more commonly n up to 15, for example. But n up to 12 is also possible. So first, if you see low constraints, think about a slow solution, like iterating all possibilities or dynamic programming, rather than greedy approach. Greedy is more common if limits are very big. If n is up to 1 million, then it's harder to do fast enough DP. But it might be greedy. Okay, the second thing is that if you come up with any greedy, you can think about counterexamples. So let's do that here. They give us some words and we need to construct a string. What if you just take any character from the first string first? I can give a counterexample to that, where if we look at the first string, and let's say the first string is ABC or ABCC, but the repetitions don't really matter. The second string will be something and so on. And the target value is equal, let's say, B, C, D. Let's remember that the order of those characters doesn't matter. Then from first string, we have a decision between this character and this one. And can it hurt if you choose just the first one? Maybe your solution is greedy, it looks like at first string and it takes the first character that is present in target, that is needed, if we take B. Well, this is wrong, because in a moment we can get a string. The second string might be just, let's say, BX, and the second one is AA. In this case, you made a mistake when choosing B here. Similarly, if you decided here to take C for some reason, then it would be wrong if the second string was CX. Then you can improve this solution to make it less greedy, to make it smarter, like count the number of frequencies of every character here, and then it will be more difficult to find a counterexample. But if you want to do something like choose a letter with smallest frequency, then you would need to understand the proof. Why is this correct? Why is it for sure better? Because maybe there is some very special arrangement where some character is less frequent, or some other character is more frequent, but it appears commonly with some rare characters. Imagine this. Maybe here you have a choice between A and B, and both are in the target, A, B, X, Y, Z. And you need to choose whether from the first string to take R or B. This is the target. But then you have BX, BY, BZ. And maybe here A with something, AW, something like that. Even in this case, it makes sense here to take A, because B appears so many times in the future, its frequency is big, so I will take A. For sure, I will be able to take B in the future from one of those strings. But turns out that in each of those strings, I need to take the second character. X, Y, and Z, they are unique and they need to be taken from that. And it was correct here to take B, even though it has more frequency. This is how you can find counterexamples to, maybe this is how I found counterexamples here. But if you think about greedy, you need to provide a proof, or you need to find a counterexample. This is not true in contests. Leetcode contest, code forces contest, anything like that. You can guess and try, and maybe you will get accepted, maybe not. But in a coding interview, it's bad to just guess, because if your interviewer asks you, why is this correct, what will you say? Okay. So here, there is no correct greedy, I believe. how to enable dark theme, I have a add-on. It's called Dark Reader. Yes, it will be bitmasking plus DP. Right now it's not a good time for suggestions in the chat, like please solve more CSES questions. You can tell me that on Discord later. In the description and maybe also here in the chat, there is a link to the Discord, and there you can put some suggestions. I don't want to now think what I need to do in the next strips. Now's not the time. Okay, we talked how greedy is bad. So let's get to solving this problem. And I already explained the logic why you should think about dynamic programming. Because greedy doesn't work and because constraints are low. And if you already decide that, okay, let's consider dynamic programming, then there are some strings, right? Like how, do, I, and so on. And there is the target. Target in the example is wow. If you watched my dynamic programming lectures, you know that after some choices, I need to know what is important so far. And there are some options here, like I can go through this string. There are two possible orders. I can go through strings, first how, then do, then I, and so on. And I can decide something about each of them. Or I can go through the string and I can look at first letter and I can decide from where I want to take it. Those two options are possible. Actually, in any greedy solution, also those are two options. You need some order to do this DP. So chat, quick question. What order do you want? Do we iterate through strings or through characters here? Just say strings or characters in target. I think that both options are possible. So for strings here or here characters in target. I think more people want characters, and that's fine. I think that both will give you solution, maybe even the same complexity. If I wanted to spend more time, I will do a poll, but whatever. Bipartite matching if time permits? No. So let's look at this first character, and I need to take it from one of those strings. Okay, and this way I will get rid of one of those strings. Maybe I take it from how, but maybe I will take it from web. There is another possibility. So there's this connection. Then there is O. Also O needs to be taken, and it removes a possibility to use one of the strings. They don't have to be the first two strings. After making a few choices here, after processing a few characters in the target, I will be done with some strings from the input. In more general case, it is this. There is some target. Let's say that target is A, B, C, A, D, E, F, A. Doesn't matter. And there are some strings. First string, second, and so on. Well, a lot of them. I don't want to count them. Okay. We already got some letters. We got rid of some strings. So what is important so far? It doesn't really matter which exactly character I took from which string. The exact mapping doesn't matter. It won't affect your future choices. To verify if something is possible, to verify what's the possible next step, you only need to know which characters you removed. But we just go for characters from left to right, then it's some prefix, and which strings here are removed. So this state, the fact that those three are removed and those three are removed, I will just describe as some tuple. This will be information 3, because the prefix of size 3 is removed, comma, and here how to describe what subset of a set is removed. The easier way to do it is binary mask. This represents that the first thing is removed, not removed, 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 because 1 and 1, and then zeros denote not removed. Actually, this 3 is unnecessary, because the number of bits in this binary mask, it is equal to that. If you removed 3 strings, then for sure you also removed prefix of size 3 in this target. So this is redundant, we don't keep that. This is state. You can see something similar, this removing of one dimension, in the third DP lecture on YouTube, where there is problem line of wines, where you keep first and last and how many turns passed, or what is the current year. It's the same thing there, because size of interval, it says how many items you removed. You should see the similarity there. Okay, so this is the state of DP. This is what is important so far. We don't need to know that A was taken exactly from this string. We don't need to remember that this B was taken from this second character of this third string. No, just which strings are removed. So this is state. And then what's the transition? I need to decide about this next character, A. And the way to do it is to just check in which strings it occurs. It cannot be already removed string, so those 3 are forbidden. Iterate over the remaining ones, and if that string contains A, then I consider that to be a new state. I will say that from this state, from 101100, I can move to state 111100 if and only if this string indeed contains this character. If this second string, it contains character A. So given this binary mask, I know how many ones there are, I can count. Then I know what character I now need to look at. And I check if there is this character in this string. If yes, we go to that state. If the problem was about counting ways, or it was about minimizing the number of operations, something like that, then this transition would mean something like dp of this state plus equal dp of that state. That would correspond to how many ways there are. If it was count the minimum possible total cost or something like that, then we would do dp of this thing, dp of 1111, oh, not what I wanted to do, dp of this is equal minimum of itself, comma, dp of this, let's just mark it as star, this is star, dp of star plus the cost of moving, let's say +1 if it's just one operation to remove a string. But no, we don't have any of that. Instead, we just say what is possible. So dp of something like that will be just Boolean information whether this is achievable or not. And then we say if this state is achievable, then also this state is achievable. It will be quite easy in code, because more or less it will be that if dp of this 110100 is true, then dp of 11100 is true. That will be the transition, but we need some stuff around that. We need to iterate over those masks. Every mask is can be just int, and then to access a bit we can do this. This is how to check if the ith bit is on or not. If you don't again, I think it's a coincidence that so many times I'm doing this. If you don't understand this line, if you don't know binary operations, but you need to know them to do any Bitmask related problem, you can watch my lecture on bitwise operations. This is how we will check something. So it will be iterate over states of dp, question marks for a moment, then for every new string, if this bit isn't on yet, if this is equal 0, if this bit isn't on, So this is like, we find a place where this is 0. We say if dp of mask is true, then dp of mask ORed or XORed with this is true. Okay. This way we iterate over all positions where there are zeros, and we say this new mask is true. But also we need to say that this and as string of I, words of I, contains some character. But what is this character? Just like in a drawing, I said that, well, if there are 3 bits already on, if there are 3 strings removed, then apparently I'm done with prefix of size 3, and now I need to look at 4th character. If I know this mask, then there is operation to count the number of bits that are already on. It's built-in pop count, in C++ at least. And so if there is 3, then I will need to access the target of 3. Let's say character C is this, not this, target of that. For example, if my binary mask is 110100, then pop count will give you 3, so you will try to access target of 3. And indeed, if you are done with characters 0, 1, and 2, because you already took them from some strings, then it's this. Quick look at chat. I don't see important questions, I mean, related to the problem. Okay, so this is this character. I need to implement this in some way. Let's just say that this is a function, contains words of IC. Later I will improve it, just pre-compute that. Contains string S, character C. Why don't I have any coloring here? Is it because I turned on dark mode? Maybe. And that's a bit ugly coloring. Also, this can be done with find, right? Return find of S begin, S end, C is different than S end, I believe. But in my opinion, it's more important to know how to do everything, kind of in any language. Even if you don't know a language or syntax, anything like that, you can do this. You can iterate over characters. And this way you better understand the statement. Never make a mistake of saying that if something is one line, then it's constant time. This function is linear because it tries every character. Actually, typing this will run something like that. Okay, then this, we need some dp of size 2 to nth power, because that's the number of binary masks. Like if n is 3, then we have those masks up to 111. This corresponds to value 7. So from 0 to 7. Where n is what? N is the size of target. No, not really. Let me think. Is the size of target can be different from the size of words, so let's think. dp of something, dp of some mask, it says what's the, whether this state is achievable, that exactly this string and this one is removed. So the size of this must correspond to the number of words, like here 5. It will be binary mask of length 5. So here this is good. Then we access that. And that can be segmentation fault. This can be outside of the string. You can click on settings, then choose theme as Eclipse. Wait, I don't see Eclipse. Oh, yeah, it's better, thank you. But also maybe I just want to turn off the dark reader. Do they have any dark theme? Nope. Then Eclipse, and dark reader is back on. Okay. Everything is false first, but that's not true. DP of just this mask is possible. The starting state is that nothing is removed. Oh, this is true. Okay. For every string, for every word, we want to check if this word contains it, and it's not yet removed. If yes, then say that this is a possible state. Also, I will say if DP of mask is true, and the pop count is already equal to target.size, then return true. In this case, wow is of size 3. If we have, for example, this binary mask 10110, it means that you took one letter from how, one from I, one from shot. It means that you're out of characters in target. And otherwise, we have this. Because I use pop count twice, instead of copy pasting, I will create a variable. If pop count is target size, then true. Otherwise, then if pop count is smaller than target size, it cannot be bigger because we just always increase by 1. Like if target size is 3, and in my DP always from binary mask of with 5 ones, I only move to 6 ones. Then yeah, if target size is 3, just like in the sample test, when the number of bits will be 2, from that you can only jump to 3. And once you consider the 3, you will not, like, you will finish the program. Yeah, then this, and if you didn't see this situation, where 3 bits are on and the size of target string is 3, then return false. I will make some summary of what happened. Well, I understand that for some of you it's easy because you know this technique, you know dynamic programming on Bitmasks. The goal of this stream is to show it to people who are not aware of this. Taking strings of our chars will affect the size of the bitmask. We can take whichever is smaller. Yeah, Suresh on YouTube said something reasonable where we can first make an if between words.size is smaller than target.size. If this, then run one algorithm, otherwise run something else. But it doesn't really matter for our low constraints. My complexity here is obvious. It's 2 to nth power, because of this iteration, times n, times this function. The complexity is length of a single word. And they didn't really provide any limit, but I assume they are small. If they are of length 1 billion, then obviously it's too slow. You can pre-compute this, but doesn't really matter here. My complexity is 2 to nth power times n times len of a single word here. And n here denotes the number of words. I will now simulate for you what happens for this example. Augmenting paths not work. Well, any DP can be treated as some kind of graph, but DP is easier here than thinking about graph at all. Okay, let's simulate this test. Can I copy and paste? I think I changed this. Okay, now it works. Let's see what my DP will do. I first say, or maybe we should have the code on the side. I will make a screenshot to easily access that. Okay. Sorry for this. One moment. Good. Good. Well, n is 5. It's the number of words. Then we create dp of size. This 1 shifted binarily by n, it means 2 to nth power. So 32. This is size of dp. Also, we say dp of 0 is true. This corresponds to this bitmask. So dp of 0, 0, 0 is true. And from that we will propagate to some other states. If ever I will see something like this being true, dp of this is true, then I will know, oh, apparently by removing every next character here, I got to the situation possible where this is removed, and this is removed. So one character from each. So I apparently removed all characters. I matched them in some way. So I got the answer. So if something like that is ever true, then I will say return true, and I will terminate the program. That's what will happen here, but that's for later. Iterate over all the masks in order of increasing values. This is iteration from 0 to 31, because 1 shifted by n binarily, it's 32. So masks are considered in order 0, 1, 2, 3, and so on, up to 31. So first we'll propagate starting from 0, and so on. Like what this means, the 3. 3 corresponds to this bitmask, and this value is true if and only if the first 2 characters of target wow can be represented by something from shot and something from web. Why can't I modify? Okay. Or actually, wait a second. I think I should think about this in reverse. This last bit, the least significant bit of 3, it is on position 0. This is how you number bits. So this corresponds to this string actually, the how. This bit corresponds to do. So this value, dp of 00011, so dp of 3, it will be true if and only if how and do can be removed and nothing more. If I first remove some string containing w and then remove some string containing o. And yes, it will be true. Okay, so what happens here? If blah blah blah, I use pub count. I count bits here. Here it will be 2. For this string, pub count will be equal to 2. I try to access target of PC. PC is 2, so target of that is in the string character at position 2 is w. So now the character C is w. And I try to find it in some word, some of the remaining words, I, shot, web. If one of them contains w, we are good. Iterate over I, index of that string, in strings words. If this word, if words of I contains character C, we remember that this character is w, and additionally mask doesn't have this bit on. The second condition, it corresponds to checking if, for example, I is equal to 2, it will check if this is 0. And if yes, and the dp of mask, if this was true, if this state was possible, then we would say that this state is also possible. True. But what I don't think this will be true, because the middle string doesn't contain w, I, but web does. This string does contain w. This is string at index 4. This is bit at index 4. So 1 0 0 1 1. DP of this becomes true. And a bit later, when we consider this number is 1 plus 2 for 8 plus 16. So the value of this is 16 plus 3, 19. When we consider DP of 19, this is set to true, and I claim that this will trigger. If pop count is equal to target size, if the number of removed or used strings is 3, the number of characters here, and DP of mask is true, then we return true. And we can check that what I'm saying makes any sense by saying print mask and DP of mask. Run. Okay, this is 0 1. There is some nice trick to, instead of zeros and ones, print true and false in C++. I think it's called bool alpha. Then you will get words. Alpha. Yeah. DP of 0 is true, DP of 1 is true, and so on, blah, blah, blah. DP of 16 is true, DP of 17 is true, DP of 19 is true, and it's the first moment when we have true and pop count is free. Let's also print mask, this, and pop count. Messed up. Oh, because pop count isn't yet computed. What do we have? DP of 19 has value true, and the pop count is 3. There's 3 strings removed. Already previously there were some cases where, for example, 2 strings were removed, but it means that we only matched 2 first characters of target string. There also, for sure, anything with pop count bigger than 3, the value will be false. Because before you mark something of pop count 4 as true, you must get from this from something of pop count 3, and already then you would terminate the program. And here, the first time this happens, you terminate, and this is why you don't see any more printing. So we can reorder list of words and cannot read the target string, is that right? I mean, the answer, true or false, will be the same if you here put some random shuffle of words.size, oh sorry, .begin, words.end. This function, it shuffles randomly the strings. Same for the target. If I run this, the DP values will change. Let's change the random seed. For example, yeah, now DP of 13 was the first true, because I reordered stuff, so some other binary mask will be first, like 10101, maybe something like that, but it won't affect the final answer. It's just that a different binary string of length 3 is good, because the answer to the problem doesn't change if you reorder strings or if you order those characters. You can choose whatever you want order of saying, okay, let's first decide about W, from which string you take it. The thing with dynamic programming is that it simulates checking all the possibilities, so the order doesn't matter. You check all. I'm done. Looking for questions. After this, I will take suggestions from the chat about Leetcode dynamic programming problems. Yes, you can give suggestions now. You should provide a link, maybe with some very short description. Then I'm a bit more likely to take a look. Because, you know, just judging from the link, how am I supposed to choose a nice problem? and only dynamic programming today, let's say. Maybe then I should change the title of a stream. Dynamic programming in coding interviews. Like that. Cool. What do we have here? No any DP questions from Amazon? You know, the companies don't really, they all use the same problems. It's not that every company has their own problem set. Maybe some of them do. You almost shouldn't care about the source of a problem, whether it's from Amazon or Google. And only Leetcode, please. I'm looking for something with just any description. You don't need to copy the whole statement. Word break. Buy and sell stocks. Didn't I cover that once? What is this? Maybe still something with strings. Given a non-empty string S in dictionary, determine if S can be segmented into a space-separated sequence of blah blah blah. So Leetcode can be split into Leet and code. Apple, apple. Oh, apple, pen, apple. Yeah, true as well. Okay, this one is a fine warm-up. And later I will scroll again here to suggestions and will... Don't put new suggestions. I will scroll up and take one of those. Please do Knuf optimization on DP. That's too hard. That's for sure too hard for coding interviews. Because it's Leetcode, we don't need dark reader. Yeah. So apple pen apple can be split using apple and pen. These cats and og cannot. Let's see why in the last test the answer is false. Also, I will copy this into YouTube chat. We have cats and dog. Sorry for ugly handwriting. And this word exists, cats. This one does, dog. Also, D is not doubled, like that. And exists. Send exists. And so the whole string is covered with words from the dictionary, but you cannot split into them. Instead, they ask you to put splits, or like bars between them, so that every part would be a word. And then for the apple, pen, apple, apple, I will not finish. This is good because you can put splits like that. This is the second example. Okay, so this is no, this is yes. Well, you already have a hint that we're doing DP today, and generally I don't recommend while you're practicing, you shouldn't just focus too much on problems from one topic, because it helps you to know from which topic it is. You should learn something like dynamic programming. Maybe, actually, dynamic programming is a big, it's very, very big category. You should solve tens of problems, so it's fine that starting to practicing DP, you solve several problems, but then you should get back to randomly choosing problems, so you wouldn't know that it's DP. And here, you might first think about greedy. So just like with the previous problem, maybe you will try to take the longest word or something like that. Let's work with counterexamples. Dynamic programming problems, often they look like greedy at first. And you might say, okay, I need to split some long string into shorter ones. Let's say that it's doggo and then ing. Okay, and let's say that doggo is a word, but also dog is a word. You have a choice between those two, and let's say you always take the longest one. Then you might be in trouble because it will turn out that the rest is bad. You cannot split this into shorter strings. And here it would turn out that shorter is better, because there is dog and then going. Very similarly, you can find counterexample to taking the shortest. So greedy doesn't work. And if you're ever thinking about greedy, and especially if it fails you, then what about dynamic programming? Dynamic programming is like big old brother of greedy, where it will be more difficult for you to do DP for sure, but it can solve problems that greedy is not able to do. Okay, so what do we do? After, just like in the previous problem, after some time or after a few operations or anything like that, what is important so far? Okay, so here it seems quite stupid, given a very long word, to split randomly in the middle, then maybe here and so on. No, it's easiest to go from left to right. I see that several people suggested keeping the dark reader on. I think you're fine. I mean, the half of screen is black. I'm trying not to kill you with the whole white screen. Okay, we are going from left to right, just like in the previous problem. In the previous problem, we went from left to right through the characters in target. One eye good, one eye burning. But then, can you do this, or just keep one eye closed for the whole time and just look at the black part? Do you want this? Actually, I prefer to keep it like that, because if somebody is new joining to the stream, I want them to be able to see the problem title, so they could easily Google Leetcode word break, and then they will see it. Or just read the statement here. Okay, after making several choices, like maybe dog and go or something like that, it doesn't matter how you split the prefix. In order to know if you will be able to finish, you just want to know the last split. If you needed for some reason to know every split you already used, it would be a Bitmask problem again, because Bitmask would hold information like 0, 0, 1, 0, 1 about where the splits are. But it is not needed. If you used those two splits, or whatever splits you used here on the left, if the last split is here, you just need to know that it is here. So the only thing in the state will be position of this last split. We will have dp of position. Like that. Here it's, let's say, position 5. Or you can also say this will be how many characters already are used. How big prefix I'm done with. Now let's do something with the rest. And this will be false or true, because again, the question just asks whether something is possible or not, true or false. At the end, if we can split up to the end, if we can put the last bar, the last split here, we're good. I will return dp of n. Also, I need to start something. I don't want everything to be false. First, I say that this is the first split, that dp of 0 is true, because the definition of dp is dp of x is true if and only if the first x characters can be split into strings. And what are transitions? Well, if you know that this is the last split, you need to iterate over what are next things you want to use. So n is s.length, create a boolean array with true and false of size. I want here to have things from 0 to n. 0 will mean split before the first character, so, or dp of 0 is, I can write down the definition, dp of x is true if and only if you can split first x characters into strings. Also, I can shift this by a little bit so that my face wouldn't cover anything. Okay, then from this definition, dp of 0 is true, and at the end I'm interested in this, whether the first n characters can be split. This is why I need everything from 0 to n. And yeah, sometimes it does help to write down the definition like that. Also, it helps with plus minus 1 errors. Okay, for every I, well, maybe I will leave this as question marks and I will get back to this. I already noticed that sometimes I make an error of, not an error, but when I stream or when I teach, I here immediately put the correct value. But for some people it's not easy. So just like with previous problem, I will put here question marks and we'll get back to this. We will go together through what these values. You can already think whether this is n plus 1, n minus 1. It's very important to know exactly what to put there. If you can use this, if you can split the first I characters, then there are several options. I can iterate maybe over the next index, the next split, so kind of from I plus 1 to something, maybe like that. Either this or slower version, iterate over strings in the dictionary and check if this string matches the consecutive characters from this moment onward. If you have dog going and you are here and you have in dictionary a word goes, goes cannot be used here because it doesn't match this. Go-I would be fine. Going would be fine. Going-ing would be not fine if this word existed. I want to check if this string matches whatever now happens from this moment onward. So I can check if s is equal, I need some substring function and I never remember what to put there. Oh no, s is the main string, so let's here use d for string in dictionary. I want to check if this equal s.substring starting from I, and here it's length or the final position. I think length. d.length. If this, then dp of I plus d.length, maybe plus minus 1, let's think in a moment, is true. Okay, quick Google, C++ substring. Yeah, it's first position and then size. I'm not wrong. So substring starting from position I, take that many characters. For example, if we have our dog going and I is equal to 3, it means that I'm already done with the first 3 characters, dog. I already used that as a word, or I split this into smaller words. How can I donate? You cannot. I don't take donations. Okay, this is already split into smaller words, and now we want to check, for example, for a new string d equal goes, because this is in dictionary, we want to check if going is equal to goes. This is what happens there. And then dp of what? If yes, then I want to say that splitting up to this position is fine. If the first 3 characters were fine, then I add 4 more. Now 7 first characters can be split into smaller substrings. Then I just add this length. Like 3 plus 4 would be 7, because now prefix of size 7 can be split. And this is true. It's easier for me to understand because I wrote down the definition. The definition is whether the first x characters can be split. And this can give you segmentation fault. It's not that you would lose all the points in your coding interview because of that, if it was like a live interview with a human. And if it's instead in Leetcode or HackerRank, you will just get some segmentation fault, even on sample test, because here you might go outside of the string. Imagine what happens if you have string, and then starting from E, you want to match this with some string like EF, FF, this. You cannot take this substring if you start somewhere close to the end and you want to take a lot of characters. So here we need some additional if. If I plus d dot length smaller equal s dot length, I believe. For example, let's dog going. It's very convenient to use a particular example and just figure out this plus minus 1. If you're done with dog and now there is something of length 5, like going, it's fine, you can compare. But if new string was of length 6, then it was bad. So 3 plus 5 smaller equal 8 would be true. You are allowed after dog to check for string going as this substring, but 3 plus 6 is greater than 8. You cannot now take a substring starting from this position of length 6. Yeah, that's good. So indeed it's exactly this if. Yep, I think it's everything. There are no segfaults because substring is greater than d. Substring function takes care of that. Then what does it return? Yeah, if or until the end of the string, whichever comes first. Cool. Then in C++, because there is no error and then it just shrinks the return substring to whatever is possible, then we're good. So we don't need this, and it's just that some string will unnecessarily be compared. Like for dog going, if you want to compare with something of length 8 starting from here, you will just compare going with something of length 8. You will do some unnecessary work, but it is not an error. By introducing this extra condition, your program will be just a little bit faster. And what are question marks? The last state from which we want to transition for dog going is this one. If maybe you partitioned those, and this might be a new word. So the last state from which you want to transition forward is the one where n-1 characters are already done. So you could do this, but it's a bit more common to do that. Another explanation is we return dp of n. If from dp of I we only move to bigger indices, like from I to I plus 1 and 4 onward, then it doesn't make sense to move from dp of n to the future, because the future doesn't exist. dp of n is the last possible state. From anything before that, yes, we move forward. Let's run and submit. Expected bracket. Yep, I'm lacking a bracket indeed. Operator equal first compares sizes. Yes, but still the substring function is linear. So I said that this makes your program faster. I still claim it does. Even though here comparison will take constant time, I believe, and this is what somebody said in the chat, for two strings of different lengths, still just taking this substring will be linear. So thanks to introducing this extra condition, sometimes you do O of 1 instead of this being O of, well, length of the suffix. It does improve. Or do you claim that that compiler will optimize this? Very smart compiler could figure out something here. It could figure out that if something is not true, then this comparison cannot happen. But I don't think compilers are that smart. I think that this will be done linearly because of the substring thing. Substring, I would expect this to work in linear time because it creates a new object, right? Yeah, it must. I don't think it's possible to implement substring to just return some pointer and only do it work in constant time. I still claim that this is linear, but yes, the comparison should be constant. 20 pixels. If I'm not right, please say that. I don't want to say something wrong for sure during a stream. So it won't be linear if you use string view. I don't know what is string view. So I will leave that as homework exercise for whoever wants to do that, but I would just do this instead of string view. Can we have a drawing? Yes, we can. I can work through an example, for example. We can go through the sample test, for example. Okay, and also complexity. N, that's the advantage of iterative DP. It's very easy to say the complexity. N multiplied by the number of words in dictionary times its length, and this is also related to the length of that. So it's O of n multiplied by words count multiplied by word len, but this can be simplified to just O of n times sum of lengths. Iterating over all strings in some dictionary, in total, if for every string you do linear work related to length of that string, in total it's just sum of lengths. You don't care that if some strings are of length 2 and some are of length 1000, you care about the average case. Then this is a bit better notation of complexity than this one. So it's n, length of this string, maybe I should say s dot length. This usually denotes, plus sum of lengths of in dictionary. Okay, that's the complexity I would say this program is. Though I think maybe we can do better if we don't iterate over string and instead if we iterate over indices and we use some map, but we can get to this later. Let's do a drawing. Snapdragon already said that it depends on the return type of substring. If it returns string view, then there is no profit to the extra check. Substring will only return a string view if you first cast s to string view. It's not automatic. Okay, so if we work with strings, if s is a string, this is linear. and I understand that there is some similar structure, string view, where it will be better. Would you be doing that geometry problem that you rejected some time back? Not today. So some drawing. Let's consider dog going. Whether we can split everything up to this position, if it is possible to put some bars here and everything in the prefix would be split correctly, we would say that this is dp of 4 being true, because it's about first 4 characters. Okay, that's the definition of dp. I will return dp of 8 at the end, whether this can be split into strings. I start by saying that the first 0 characters can be split. Otherwise, always all the dp values would be just false. So I just say this is true. And let's represent true as this green bar. Iterate over all strings, and let's say that one of strings in the dictionary is das. Then what do I do when being here? I want to check if starting from here the word das exists. It would need to be equal to this. So this s.substring starting from this position of length d.length, this will take dog with double G and it will compare with das. This comparison will say if das is equal to dogg. Well, it isn't, so we will not mark this. But if it was true, then I would say that dp of 4 is true, that this is also possible. But it isn't. But then there is word, for example, a word dog. Also, let's ignore everything that is above. For dog, starting from this, I take the next 3 characters. I compare with the string. They are equal. So this line happens. dp of I plus 3 is true. I mark this as true, and I can write it down. dp of 3 becomes true. Maybe also a word doggo exists. Then I will, still being here, I will mark this as true. And later on, I will be, okay, what happens when I'm here at I equal to 1? I will not propagate from this, because d cannot be split into smaller words. Oh, by the way, do for sure is also a word. From this I will not propagate. So even if outgoing was a word, I wouldn't now mark this as true, because d wasn't a proper string I can split into smaller parts. But from I equal to 2, notice that I iterate over I, over where the last split is, and I say if dp of I, if everything up to this point I could split into smaller parts. Then iterate over strings like dog, das, and so on, and check if starting from this position the next characters are good. Later, when being here, and if one of the strings is going is in dictionary, I will compare this with going, and I will say dp of n is true. And then at the end I will return dp of n. Any suggestions on how to find correct order of evaluation in multidimensional iterative DP? Yeah, always. The rule is just if there can be transition from state 1 to state 2, then state 1 needs to be considered first. That's it. That's the only rule. If there can be transition from state 1 to state 2, state 1 must be considered first. And choose whatever order will satisfy that. But you can learn about this in more detail in my dynamic programming lectures on YouTube. I'm not now advertising some paid program. It's free. I have YouTube lectures for this. In general, you can use any topological order. But instead of knowing what topological order is, just assume that if state 1 can transition to state 2, then you need to consider it first. Machu Picchu, I will not answer this general question. Practice and you will get better, that's it. Does this solution have some sort of name? Iterative dynamic programming. By the way, I mentioned that there is maybe another solution, maybe it's faster, I'm not sure about that, where we have our string dog going, and when being somewhere, instead of iterating over strings in dictionary, I will now iterate over where the next split is. I will keep this prefix, like let's keep some temporary string, let's say tmp. Initially it's empty, then I add g, I add o, and so on. At some moment it will be equal to goi, this, and I say if this, I need to check if this is in some dictionary. Here I can cast word dict to a map, or in Python it's called dictionary. So I could quickly check if something exists in dictionary. And then always I do, if this string exists in the dictionary, then this becomes true. Then the next operation is tmp plus equal n. Like I add character by character. This way I don't have this iteration over things in dictionary. If dictionary is very big, then my new method is better. The new complexity would be O of length of s multiplied by, starting from every position, I go onward, I keep increasing the string, and for every position I check if this is in dictionary. So that many things I will check, times I check if it's in dictionary in this time. Yep. The solution is roughly like this. For every I, now for every j, I will not code it fully, you can do it if you want. For every position starting from this one, tmp plus equal s of j. First it will be g, then go, goi, and so on. If dictionary contains tmp, then dp of j plus 1 is true. I think it's that. So the complexity is n multiplied by checking if dictionary contains some string. Then the complexity of just is length of this string. It's also limited by n. So this is O of n cubic, where, well, n always denoted the length of s. And this can be worse or can be better than this thing, because dictionary maybe is huge, or maybe it's much smaller. If there are like 100 words in dictionary, each of length 100, and this string is also 100, then those two methods are the same, because this is 100 times size of dictionary is 100 times 100, length times number of stuff. But if there are like a lot of words in dictionary, or if the string is longer than average word in dictionary, we can decide which one is better. But this is just, I don't want to go into detail and submit this. Also, this can be improved with hashes. If you just maintain hash of this tmp, then you will get rid of this and it will be n squared. But I don't think it's required in coding interview. Because checking this in dictionary takes doing this. If some map, I don't know, count or find a string s, this takes linear time, O of s, because you use this string s, you compare it with some other stuff. But I think somebody in the chat already suggested we can use try. If you use try, it will be just n squared or s squared, because when you keep appending those characters, you just move in the try created from dictionary. If you know try, then you know what happens here. There's no need for me to explain. If you don't know try, then I don't want to now go through the whole lecture on try. But I think with that we will do it in n square, and that sounds like the best solution. This would be the intended solution in a coding interview. If I continue with recursive DP, will there be any problem? Most of stuff can be done with both versions. You can do recursive DP if you want. In my opinion, iterative is better. I explained why in DP lecture. We've tried the complexities of s times max length of word in dictionary. Actually, we've tried it will be sum of lengths in dictionary multiplied by n squared. This is to, not multiplied, sorry, added. This is to create a try from the dictionary, and this is then to, for every position to move onward, and also as we do that, keep going down in a try. Maybe this will finish earlier if this try is very not deep, shallow. Like if the depth is small, then it is limited by n times depth of a try. But this is also just length of stuff, so it doesn't matter. We can do this, or we can say minimum of n comma longest string in dictionary. But most likely this longest string isn't really smaller than our string s, so let's just go with n. Okay. I will leave it like this. Recursive DP is easier to grasp the concept. And I will not argue today about this. You can watch my lecture to see my opinion about it. We are done with the problem. Why is there spam on YouTube? Please talk in English only. You know, during my streams where I solve problems, just try to keep talking about the problem, not really about unrelated stuff. You can join the Discord server if you want to sometimes also talk about off topic, or just ask me about a general thing related to programming. Let's do one more problem today, and let's make it not about strings. As I said, I will scroll up. I told you already that I will not. Also, join the Discord server if you want. Link is also here. And on my YouTube channel, you can watch all the past screencasts, also the current one, if you ever want to do it. And next stream on Saturday, in 2 days, we will solve easy code forces problems. Hard DP problem. Strange printer. Sorry for white. There's the printer can only print a sequence of the same character each time. At each turn, the printer can print new characters, starting from and ending at any places. I would prefer to avoid characters again. It's not really a stream just about things with strings and characters, but the problem is fine. It's related to stamps. I already in one of the streams told you what needs to happen if we can overwrite the current string. You might remember what we need to think about then. Super egg drop. Didn't I cover it? This one I anyway want to do on YouTube, on the main channel. I need to get back to making videos for the main channel because it will die otherwise. Binary tree cameras. Given a binary tree, we install cameras on the nodes of the tree. Can monitor its parent, itself, and its immediate children. Okay, let's do this. That's something completely different at least. But also, let's say that a strange printer is a homework. Yeah. Maybe super egg drop and strange printer. Yep, I like this idea. Those two will be homework problems. Now let's do binary tree camera. That will take 20 minutes, I guess, and we are done for today. Yep, decided then. When may I ask you, Errichto? I told you, if not related to the stream, join the Discord server. Do an extra stream when you hit 20,000. Am I close to that? A long time ago, I stopped caring about stats. Oh, that's very close. Let me check. If you don't know, on Twitch, I stream on Twitch and double stream also to YouTube on Errichto 2 channel. I'm going to rename it to just Errichto Live or something like that. And there is also the main channel. The main channel is much bigger. But also I kind of hesitate to make videos there because I want them to have good quality, so I need to spend a lot of time. When here I just stream, that's easier to do. I need to fight with this this approach of mine. Yeah. Here you can see screencasts and broadcasts of recordings of streams from the past. But I want to see analytics, and because I should have access. Yeah, I do. I have access. Can I show this to you? Yeah, I can. Okay. 19,919. So we will not hit this today, like during this stream. Likely it will happen. Let's see, 2,000 divided by 100 a day. Yeah, it will happen tomorrow. Maybe I will go live for like 1 hour to play some games. Maybe. But also it might happen during a night. Okay, binary tree cameras. I'm changing link for Twitch. Done. YouTube, you can grab a link too. Within a binary tree, like this one or this one, we put cameras on nodes of the tree. Each camera at a node can monitor all neighboring vertices or nodes, its parent, itself, and its immediate children. Calculate the minimum number of cameras needed to monitor all nodes of the tree. Again, either we do greedy or we do DP. And this time, I think that greedy is possible. It's always funny when, let's say, in university a professor says that something is trivial, a student asks for a proof or something, and then professor needs to think for 5 minutes or 15 minutes. And then after that thinking time, he says, yeah, it's easy. So here it is, greedy is easy, I think. I don't see an issue. But instead of talking about greedy, we will try dynamic programming to stay true to today's topic. What problem are we solving? 968 binary tree cameras. How to do dynamic programming on a tree. It doesn't have to be binary tree, but it can. Like that. Well, you need some order of doing stuff. And this time, left to right doesn't seem so convenient. Like, yeah, there are some things like pre-order, post-order, stuff like that. And actual dynamic programming is done in one of those two ways, but we shouldn't really think about it so much. We should just do recursive DP. Recursive DP is much easier for trees, especially if we are given that with pointers. There are cases of very difficult problems in competitive programming where you need to treat a tree as something, as some kind of sequence. When you do pre-order, you save that as a sequence and you then have some intervals, stuff like that. Doesn't matter here. In coding interviews, we do DP on trees recursively. What does it mean? It means when we enter some vertex, like for this one, I want to, after exiting from this vertex, you just think about DFS. DFS visits a vertex. When visiting a vertex, it goes to two children. So while being here, first it goes there, then all this subtree will be done. Then we go up, then as second guy we visit this one and everything below. And only then as the third step we see this thing. So this is what? Pre-order? I don't even know names. They are not important. Post-order, yeah, this is called post-order, I think. Where we first go to both children and then we do ourselves. But after going to this left child, we process the whole subtree. So what about this child? Returning to us the DP value for that. If we care about the minimum number of cameras used, then maybe this subtree should figure out what's the minimum number of cameras used there. Let's say it returns 2. Also this right one, it will figure out some minimum number of cameras used, maybe like that. It will be 3. And then we will combine that. We will say that in total for this whole tree, the number of cameras needed is 5 and maybe this guy. How to decide if this guy is needed as well? Well, we would need to know if one of those two vertices, if it contains a camera. So they shouldn't really just tell us 3. It should tell us 3, comma, and here false or true, whether the root vertex of that subtree, so this guy, whether it has a camera. Similarly, this left guy, it will give us 2, comma, false. Because optimally here we put 2 cameras and this thing is false. Actually, it's not optimal here. In this subtree can be done better. But it's just an example. How to do it better, we will see in a moment. But if both children are false, then it means I need to put it there. So I will myself, this root, will return 3 plus 2 plus 1, because I need to put a camera there, comma, true. This is what I will return. And you might say, well, I need to return just 6. The answer to the problem is 6. So what about just returning 6 and not caring about that value? This is not how you should think about DP on trees. You should think that you're in this vertex and you need to compute the DP, whatever DP is needed, and return it. Because maybe you're not the root of the whole tree. Maybe you're actually a child of some other vertex, and that vertex also has another parent. They have more children, and so on and so on. So when we are at some vertex, and we have 2 children, and also possibly they have children, so the whole subtree, I don't care at this moment if this is a root or not. I just know that I have some kind of DFS / recursive DP. Recursive DP is just DFS, and it returns something at every step. I don't know what is above me. I don't care. I just need to say what my children need to give me so I could give the same thing to my parent. And here, because we minimize cameras, then for sure I need to know what's the number of cameras used on the left and on the right. But then to decide if this is a camera, I see that, oh, I have some extra stuff that my child needs to give me, the false true thing, whether the camera is here or not. Same here, and then I can indeed combine that. Maybe then it would turn out that I need one more thing. Then I need to add this one more thing as state as well. But here it's just this. Why did I say that this is not optimal on the left? Does anybody see? Question to the chat. Why is 2 false not optimal for the left tree? We would need to handle separately leaf node, correct? But that's a detail. No, that's like doing n equal to 1 case. I always start solving a problem by doing a general case, and then at the end think about any kind of edge case. Other order is stupid, because maybe your solution will not have edge cases, or maybe you will not solve it, then you just wasted time on n equal to 1. Because root is not covered, we can use one node. Can be done with one node? No. One node is not enough. If you put it here, then this guy is not covered. If you put it here, if you put it there, then those leaves are not covered. One node is not enough, but you can do 2, and you can make the root better. A moment ago, the situation was like that. It's not optimal, because it's more helpful for our big parent above to do it here. We minimize the number of cameras, obviously, but in case of ties, I want this to be true if possible. And here, false was not optimal. Optimal was true, because this is possible. And indeed, if you focus on that, I mean, we're not quite there yet, but I just wanted to explain why this is not optimal. Similarly, it is the same for the right child. We can do this. And then this is not false, it's true. We covered the whole subtree and we put true here. 2 and true is better. This is true as well. And the logic will be, take the sum of those 2 values. If any of them is true, then you're fine and you're yourself false. Otherwise, like add 1. The logic is return a plus b plus possibly add 1, but this do only if both children are false or they don't exist. Comma here, this 0 or 1, also it depends on whether if one of children is true, at least one child. But this will not work quite yet. Yeah, Snapdragon is explaining this right now in the chat. But indeed, what I'm doing right now, it's not really DP, it's greedy. You make decisions for children, not caring about the future. That's called greedy. There is no DP here. Similarly, like if we had those other problems previously, what did we have? In this dog going. If I just looked at that first split and said that I choose some word like dog, and I say that's the split I'm using, that's greedy. If I consider many possibilities, that's DP. Here it will turn out that we need to consider many possibilities for subtrees. And then when we are here at parent, we will need to consider many possibilities for each of children. And let's see why. It's impossible for us right now to create this situation, this optimal situation for left tree. Let's actually copy this, if I can do that. Let's say that we're solving this easier case. What will this guy return? Well, if he just doesn't see the outside world, he will return 1, true. And indeed, if there was nothing else, then this guy needs to have a camera, So we have that. What about this one? It's also 1, true. Yeah. And then when you are here, you try to combine the two children. You will see that both of them, they already have cameras. Maybe this, let's not use this in red. So you will combine them, and for this parent guy, you will say 2, false. This subtree can be done with 2 cameras, they are here, because this is how optimally to do subtrees of children. And here I don't need a new camera. This is bad. This is bad because for children I greedily did something there to fix them, but maybe like the future can fix them. It's not good when having some vertex and maybe their children. It's not good to, based on what I did already there, to decide about whether the camera should be here or not, because we don't know. Maybe it's better to put a camera here above. Maybe later it will turn out that this is a good place to put a camera because the outside world looks like that. Imagine that this is a whole tree. It's very stupid to say that if this doesn't have a camera and your children don't have a camera, so there is no camera in those 3 vertices, this one, and this one, then you put a camera here. No, don't do it. Maybe your parent will have it. Dynamic programming is about saying dp of here for various states. I want to know what is the best. Or after, let's remember this, the sentence I'm always repeating. After we make some decisions, what is important so far? So what is important for this subtree? This time it's not that easy, so I will write this down. Like in the previous problem, I just needed to know the position. Up to what character, I split everything into shorter strings. So this was important so far, after making already some choices. And here the choices are made in a subtree. I already put cameras in subtree. What's important here? Well, just like position is important in the previous guy, I want to know vertex v of the root of this subtree. So I need to know about what subtree I'm talking about, comma, how many cameras I used, because the problem asks me to minimize that. If it asked me to maximize, also I would put cameras here, it's just that I would want this to be big. Comma, also, after somebody already put some cameras here, you don't care where exactly they are, if they are neighboring or not. You only care whether there is camera here in the root. One more thing will be important too, but so here a Boolean value is root covered. Is root covered with a camera already. Or actually there are, I kind of cheated because this can mean 2 things and we need a combination of that. After we put cameras in that subtree, in this thing, everything that I will mark now in blue, so it's this. After cameras there are put, then there can be 3 states of what happens here with the root of the subtree. What are those 3 states? The 3 possibilities. One is that it actually, so this part, this thing, actually there are 3 possibilities. The camera is there, so has camera, and then we will know that my parent is already covered, it's monitored by a camera. Oh, like that. Okay, and maybe I will make a better drawing. This is our vertex V. There, it has some children, maybe grandchildren, just the whole subtree, like that. Also, maybe it has parent, maybe not. Right now, we are in the FS and we want to know something about that subtree, about putting cameras in this thing, like that maybe. So maybe this guy has camera, then I know that my parent doesn't need a camera, it's already monitored. Or maybe it's like that, where also this is impossible because this guy is not covered. Yeah, now it's good. Or maybe it's like this, where it doesn't have a camera here, but it is monitored already by some guy, by its child. So the second, here, this was first possibility. The second is just is monitored, is watched over, like that. And the third one, also possible, is like this, is that it isn't monitored by any camera, and it is allowed because maybe his parent will monitor over him, will watch over him. It is possible. After you put cameras here, 3 things can be about the root, those 3 things. I will write down now the third one, and each of them is possible, and each of them can affect your future choices, because it can force you to put a camera here, or it can say that, oh, it's not necessary at all. The third possibility is still needs like parent camera, needs camera nearby, or needs to be monitored. And without knowing exactly what is the layout of the rest of the tree, you don't know what to put here. This is why simple greedy doesn't work here. It is possible to solve this greedily, but then you don't put cameras in leaves, you put them in parents of leaves. It isn't that easy, but we're doing dynamic programming solution. Does cameras mean the number of cameras in the subtree below V? Yes, this thing means how many cameras I put there. This is, okay, so this is more like pointer. Let's, I would need this in iterative DP. Let's say that this is kind of obvious. DFS of some child node will return DP, so we know what that node is. This is not really important in non-iterative DP, but we could pass it, doesn't hurt. Child will return the number of cameras and this state, but it's not that it will return some particular state, 0, 1, or 2. For each of them, I want to know the best possibility. Every dynamic programming is like this. So, in general, if you figure out that in a state you need some x, some y, some z, and the statement says that you need to minimize y, then from this you create this DP, int DP of x and z. So for this particular value of first and third thing in the state of those two, this int will represent the minimum y possible, or maximum y, whatever the statement tells you to do, or yeah, just y is minimized or maximized. Okay, that's the general formula, the general recipe. And here we need to minimize cameras. So for particular node and particular state, and there can be 3 of them, we will do that. So in code it will be dp of iterative version. Iterative version will be int dp of v and 3. This is 0, 1, or 2, the state. For that, for every like dp of v, 0, 1, and 2, for this particular state, and those 3 states I wrote down here in red. Oh, sometimes one node does crazy things. What is the minimum number of cameras used to achieve this exact state? But we do recursive DP, that's much easier to do with on trees. On trees, DP, recursive DP is easier than iterative DP. So just for every vertex, your child will return something, your other child will return something, and you need to use those 2 values. Because you know what vertices they are, you don't need to like store this globally or anything like that. This is kind of, you know what the ID of your child is. So this child of yours will return 3 values. For example, maybe it will return 4, 4, 3, something like that. It will mean that for the first of those 3 red states, 4 cameras needs to be used. For the second state, 4. For the last state, 3 cameras. This one also has some possibilities. I don't know if this is possible, whatever. And you need to combine them and this guy also needs to return some free values to its parent. And that's the dynamic programming solution in this problem. Yeah, CS key in Twitch described the state 0. I think you changed the order, but one state will be has camera, so also is automatically covered, monitored over. The other is doesn't have a camera, the root of a subtree, but is monitored by some child. And finally, doesn't have a camera and isn't monitored by a child. Same recursion as building segment tree. I don't know. I don't build segment trees like that. How do we do iterative DP on trees? Let's just say that if it's given like this with pointers, you don't. If you're given a tree with pointers, you never do iterative DP. This will work in 99% of cases. Personally, I just have two states. Yes, Snapdragon, I agree with you, but okay, I will explain that in a moment. Thank you. Good suggestion. I will not implement the solution. Let's say that. Did we ever do the code review? Anything like that? I'm wondering, I'm considering adding this to homework, but the fact that you already know a solution, implement that. Yeah, this returns just a single integer, so we need a helper function. I will do pseudocode, but let's say that something returns a triple of values. You can return a vector or a tuple, whatever. Call it DFS or DP, whatever. This should create such a triple for the left child, grab it, DFS of root left, triple B is DFS of root right. It should combine in some way and return the combination with some logic. Like if I know that left thing has a camera and right isn't covered, that do I need to put a camera here? Maybe not do I need to, but what happens if I do? And yeah, I would like to give this to you as a homework. Obviously, if this problem is easy to you, don't bother about it. But if not, then do it. And next week I will try to do code review for a few of you viewers. I'm not yet sure how to do it. Let's just say that you need to be part of Discord server to take part in this. In the YouTube channel on there, in the channel about streams on Discord server, we will discuss what exactly to do it, how exactly to do it. Okay, because I'm not sure now. Snapdragon said something nice. We don't really need free states. If you look at the child, then yes, like those free states are needed. But how they affect a parent? Okay. The only interaction with parent is whether we put a camera in a parent or not. Those are two possibilities. If I have a camera, then my parent can have a parent. If I have a camera, then my parent can have a camera, but doesn't have to. If I'm monitored, then no. I think we need free states. I for a moment believed that the only two states are like what happens if my parent will have a camera, what if he doesn't. But this is more like top-down solution. Let's write down the two possible definitions. dp of 0 v0 vertex v0, it's minimum number of cameras used in subtree of v if, and here one of those three possibilities, if let's say we put camera at vertex v. There are two more possibilities. And you will not have some big array in your code, so this dp of v you can ignore. Just dp of v0, it means that it's in that triple that vertex v returns. If v doesn't have a camera, node v, but if v is monitored, only monitored by its child, because this is what happens after we are done with cameras in a subtree. And then this is, if v is not even monitored. Also, I'm surprised that this is in yellow. I didn't know that this is any kind of keyword. Also, I don't know why this is not colored. Okay, this is one possibility. The other, maybe easier to do, dp of 0v, is kind of thinking that first we decide about the root and only then go to the two children. dp of v0 mean cameras you need to use in subtree of v, assuming that parent of v has camera. And this is mean cameras used in subtree of v, assuming that parent of v doesn't have camera. Those two states should also be enough. This comes more from thinking that maybe first somebody told us what happened in the root. You decide about the order of decisions. dp is some tool to speed up process of deciding about every vertex. Okay? Just like in splitting into smaller strings, we could go from left to right and make a split, and so on. Or we could go from right to left, or we could split in the middle first and then do both halves. We can decide about any order, and dp is just there to speed this up. If you assume that this process to speed up does something from leaf up, so first it will do two subtrees with children, then you will decide about yourself, you will get this dp from that. But you will think more about, okay, let's take the root of the whole tree. There are two options for that. Either it has a camera or it doesn't. If it has a camera, then tell your left child, hey, your subtree needs to be done in such a way that everything is satisfied there, and also that left child of the root, it's already covered by a camera from a parent. Same for right child of the root. Or maybe that guy, the root, doesn't have a camera, but then, yep, this is not enough. Snapdragon, do you agree that this is not enough? Because here, mean cameras used in subtree of v, assuming that parent of v doesn't have a camera. How do we say if we should satisfy that parent? If you tell your left child that parent doesn't have camera, maybe it should cover you, maybe not. This is that case of professor saying that something is easy and then thinking for 15 minutes about it. Fortunately, it's not a hard problem in terms of competitive programming, so I don't need to think for 15 minutes. But this is not enough. But also it's a good lesson to you that if you are thinking from the other side, that also it's important here to understand why those two states are not enough. That's my point. If you decide about the root first, still your child can be done in two different ways if I don't have a camera, because that child can have a camera directly and then he will point to us and they will cover us, but also maybe it doesn't have a camera, but then my other child needs to have that camera. Snapdragon state was not about parent but node itself. You ignore the fact that the child can cover the parent for DP of V1. I mean, I do. You're saying that I don't see something. You're still saying that two states are enough? I still think two states are enough. Oh, first monitored is color yellow because there are brackets after that. Oh, you're right. Which means editor notices as a function. Okay, yes, you're right. Interesting. If you go from parent, you can follow both scenarios. Root has a camera or not, and then figure out which of two has fewer cameras. Oh, it doesn't matter which child has fewer cameras. That's not about that, because it's not that if left... It isn't true that if left subtree is much smaller than right subtree, and then obviously it will have fewer cameras, it doesn't mean that I need to put camera there or not put it there. The issue with this is that I assume that I wrote down the definition correctly, and that's the first very important step in doing any dynamic programming, to understand what is the definition of DP. If you're not sure about it, write it down. And yeah, if you're doing a tree, after you decide something about already a bigger vertex, so you color that one first, you choose whether to put camera there or not, and then you go down to a subtree of a child. Maybe that one has camera, then sure, this is well defined. But here, min camera is used in subtree of V, assuming that parent V doesn't have a camera. And then, how do we say if this parent is satisfied? How we choose cameras in subtree of V, it can affect or not affect parent of V. It can monitor him or not. So in the case where, what if the root of the whole tree doesn't have a camera? How do we say that one of the children will satisfy them? If we just tell to both children, hey, what's the minimum number of cameras used for you, assuming that your parent doesn't have a camera. They will color themselves. They will cover each of them. They will monitor each of them. Sure, but either left or right child, they need to monitor the parent. I think you're right. Okay. So after 10 minutes of me thinking whether something is true or not, I can say, oh yeah, it's obvious. No need to discuss that. Yeah, that's fine. I also thought, after you said that, I also thought that 2 states are enough. But no, so 2 states are not enough. This DP of V1 you need to distinguish into 2 cases, where you need to monitor your parent or not. And then basically it becomes that. I see that CSK again wrote down some complicated definition. Camera. State 0, strict subtree. All the nodes below this node are covered, but not this node. Normal sub replaced camera. Yes, I think this will be a good definition as well. But let's say that this is enough for today. And this is complicated to code, but you can try. And if you try, I will announce shortly in Discord how we do this code review next week. But let's add this to homework in some way. As homework, I will you implement that, I will review a few codes, plus additionally solve those two, super egg drop and strange printer. For those next week, I will mainly just talk about solutions. So that the homework next week will take 1 hour for sure. I don't know the rating of this problem in Codeforces. You can compare yourself. I never know what are ratings. When encountering a greedy problem, how are you assured that greedy will work, not DP? I try to prove it. When I think about DP, when I think about greedy solution, I try to prove it or find a counter test. With more experience, you can better guess if it's good or not. Like, I can find counterexamples quickly. And like, it's not that here when I talked about, let's say, this dog going, I could in seconds come up with counterexample to something like take the longest string matching the prefix of the string and then continue, or take the shortest. Thanks to the fact that I can quickly find counterexamples usually, I can almost assume that if I cannot find a counterexample quickly, then apparently it's good. It's dangerous because maybe it's just that counterexample is harder to find. But if you're better, it's easier for you to just try to find counterexample for 1 minute. You don't succeed, then assume that it's correct. It's not really a golden recipe. There is some intuition to it. But also sometimes proof is easy. You just see that, oh, this is the best. Here, there is no reason to say that going further to the right is better, because maybe you will be stuck. That's why any intuition to say why taking longer string is better, the intuition fails, not fails. There is no intuition saying that taking long string is good, because you might be stuck there. So, wrong solution. Easy. Like, even without counterexample, I'm sure that it's bad here to take the longest possible string. That's how to decide if greedy is good. And if not, then you think about DP. But also constraints are a hint. Small constraints, DP. Big constraints, greedy. Again, not a golden rule, but something that might help. Let's finish the stream. We're way over 2 hours. So final reminders. Those 3 problems are homework, where binary tree cameras, you implement a solution. In Discord, in some way, I will gather your solutions. I will review a few codes. The other 2 problems are just for you to think about the solution. I'm pasting this both to YouTube and Twitch chat. This is a homework. Thank you everybody for watching. Join the Discord server for more discussion. Saturday, in 2 days, Codeforces Easy Problems. Then next week we will do 1 hour earlier from now on, because of the daylight saving time. Always on Twitch. You can find my calendar here below this schedule thing. Also there is link to Google Calendar right here. I think it should work. Yeah, this. And see you on Saturday. What time is it for me? It's 8:30 p.m. Okay. Bye guys. Oh, right. Programming. He always does coding game. No, that didn't work. Right. he will have more to do in 2 weeks because there will be a big AI challenge on Coding Game. I will also take part, as I said some time ago. Again, thanks for watching. Bye.